Hey guys, ScannerDanner here with my son Caleb behind the camera at my brother's shop as usual. We are working on a 2014 Nissan Versa today, and this is actually from my friend Pete Latour, who sends his problem cars up here at my brother's shop now. So we still get to help Pete out. But this is one that I believe has a park neutral switch code, and I believe the park neutral switch or transmission range switch was already replaced, and we still have the same fault. So 2014 Nissan Versa, let's take a look and do a code scan here and see what we got. It's another Nissan. We're so excited to work on another Nissan today. This says performing system call. What the hell does that mean? And why is it taking so long? Performing system call. I didn't even do anything yet. I used to love Nissans back in the day. They used to be good cars. Dude, that was ridiculous. The amount of time it took to pull this screen up was ridiculous. Code scan, we'll just do a full one. Transmission range A circuit input. Fix it. I pushed the fix it button. It says when TCM does not receive correct voltage signal from park neutral position switches 1, 2, 3, 4 based on gear position. Code also sets if no other position but P is detected from N position, park neutral position switch inside the trans. Includes 4 position switches. What? Check for other positions but P is detected from N position? PNP switch. TCM, which is located inside the transmission, uses signals from these switches to determine shift lever position. Manufacturer does not supply any internal transmission pin testing information at this time. Scan for SLCT LVR, so lever. Select lever position. If scan value doesn't match actual select lever position, check shift cable adjustment. If okay, with ignition off, unplug transmission connector, check for loose pins. Text report that corrosion can be a problem. If okay, reconnect trans connector. Key on engine off, component test meter set to DC. Back part of the TCM connector pin 6 to a known good ground. Should be ignition positive. Okay, so I need to familiarize myself with this code. This P0705. I'm gonna start it. Battery voltage is getting low. Down to 11.4. Let's see, on the dash, we are showing that we're in park. We're in park. Reverse, neutral, drive, low. So the indicator on the dash is working like it's supposed to. Just a quick observation there. Let's see what we have as far as data parameters go. So it looks like separate switches here. So this is a CVT transmission, 4-wheel drive. This thing's not 4-wheel drive. So there's gonna be stuff in here that may not be valid or part of this. So that's the reverse switch. Reverse. That indication works on the scan tool. Let's see the D position. That works. The L position, which would be...
Hey, there's one getting towed over if you want to stick around.
No!
What were the codes? I never scanned it.
Just a 705 code. It seemed to me that there was more than one. It said the TCM's inside of the transmission on this, and there's internal switches that indicate gear position that might be separate from the part that Pete changed. I'm not sure yet. I got to do a little bit more homework. I'm just checking data and the switches themselves. And right now everything's working like it's supposed to be. That's neutral. There's the park position. Like these are all working. Sport mode switch, I think that's this guy on the side. Yeah. So on the side of there's a button, and that's working too. The D range indicator, I don't know if that's like indicator on the dash, but that's working when I go in drive. The R indicator, that's working when I go in reverse. What was that right there? Oh, that was me going, just moving past. So that's low. That's all that was, just moving past reverse to get to park. It gave me a little blip there. N idle status, I don't know what that is. Don't know what that is. Right, yeah, so all of these, from what I can tell, are working like they're supposed to. Let's go codes again. So P0705, I'm gonna clear these. No, I don't wanna clear them yet. I'd like to see my freeze frame. Let's see if this code's in the engine too. No freeze frame data stored, so can't look at that. See if we can get a troubleshooter tip for this code. I just cleared them, there are no codes present. So, let us go drive this. So I'm reading that I'm in drive on the dash. I'm reading that I'm in drive here. And so I'll just let that go. I don't even have to look at it. I'll just watch for my check engine light to come on. As soon as it does, we'll pause the data, go back and look at it. And from what I'm told, this comes on right away. Yeah, this is a CVT because I didn't feel shifting. So a CVT transmission, Caleb, is a constant velocity. It doesn't have gears. Don't ask me how it works, but it technically doesn't have gears that shift. Here's some engine tapping. So when does it do it? Should we hit the drive-thru, get some food? And then we'll eat at Danner's shop while he's racking that Hummer.
It's essential to a test drive too.
Yep. My indicator on the dash is staying in D the whole time. That hasn't changed. I don't know, if we have any pending codes or not. I'm kind of basing this fault on my indicator's going to change and my check engine light's going to come on. The problem with the check engine light, though, and watching that, is a lot of these systems are what's called two-trip detection, which means we could have already had a fault on this test drive, but I wouldn't know it until the second consecutive fault before the light comes on.
That's
Boo. Boo.
Hi, looking to get searched for you.
Yeah, can I get a number 3 medium size with a Sprite? And I'd also like a junior bacon cheeseburger. Same thing. Actually, just double that. We're getting 2 of those. So 2 number 3 spicy, 2 bacon. Sorry.
Bacon cheeseburger?
Yes, thank you.
Anything else for you?
No, that's it. Should have got Danner something. Oh well. Sorry, Danner. Sorry, Danner.
too late. He gave us crappy cars.
I know. It's both bull ones. This is supposed to be immediate check engine light back on. Or 1 mile of driving, freaking it happens. And it's not doing it. We have to make sure when we get in the Danner shop, we put the windows down because fast food has a way of lingering in a car, and it's a customer's car. And they'll be like, who was eating in my car?
Yeah.
We were. CVTs are weird. Constant velocity. I don't know, they're doing some type of viscous clutch. Not really sure. I never cared to research them, to be honest with you. Very few cars use them, and I'm not a transmission guy anyway, so if you're having transmission problems with your CVT transmission, I'm gonna send you elsewhere. I've learned, like, over the years, you don't have to be an expert at everything. And there are certain things you don't have to touch. Like, another one would be like a differential and setting up a pinion and a ring gear and backlash and all that. Never cared to learn. Don't care. Never had to do it. The few times that I've had to deal with one, yeah, I just didn't. In fact, I did do a pinion bearing on a differential on a Dodge van. I had a gear noise, and I did the pinion bearing, and there was a crush sleeve. So when you set the pinion, there's a certain way that it gets done, and I didn't do it right. And when I was done, there was a groan to the differential. So that was my one time doing one of those. I didn't do it right. There was an astronomical amount of torque that needed to be put on the pinion nut. It was like a ridiculous number, and I had no tools that would do it. We ended up using like an impact gun. It didn't turn out so well. Now, electronics on a CVT transmission, I don't have a problem with that. Something electronic, a solenoid, transmission fluid temperature, a switch input, all of that, no problem. We can handle that just like anything else. But when it comes to the mechanicals and the hydraulics inside of a CVT transmission, nope. Same way with, honestly, with a regular transmission, I'd be saying the same thing. Hey, I got no first gear in my car. I'm sorry. Sucks to be you. I don't know. This video is about us going to freaking Wendy's and getting food. I should have got you something from Wendy's too. We just went to Wendy's. This isn't doing it. I got a D indicator. Do we know, is the indicator mess up too? It goes away.
Yeah, she doesn't see it.
Fudge.
So do you think, is it an internal communication
I don't know. While we're eating, I'm gonna research the system a little bit. And
Sorry.
we're gonna eat, and Caleb and I'm gonna research a little bit off camera, and then we'll maybe do a final wrap up here.
Maybe it's a connection issue, because I looked at that connector and it's like in a weird spot. I don't know.
Yeah.
Looked like it was.
Well, this was saying internal switches too, so let me research this code.
Okay.
All right, so we had our lunch, did some research on the code, showing us for the 705 code for logic as far as detection goes, is it says that 2 or more range signals damn it, simultaneously stay on continuously. You got that? Simultaneously stay on let me read it again. 2 or more range signals simultaneously stay on continuously for 5 seconds is what sets. So in other words, like, it's showing that it's in park and drive at the same time. 2 simultaneously continuously for 5 seconds or longer. Yeah. So damn it, freaking lunch. It says diagnosis condition 1 continued for 5 seconds or more. The TCM power supply voltage has to be more than 11 volts. Diagnosis condition 2 continued for 2 seconds or more. Vehicle speed less than 2 miles per hour. Accelerator pedal 0.6/8 or less. Idle switch on, stop lamp switch on. So you're sitting there in gear. I don't know, I guess the stop lamp switch needs to be on for this. But it says possible causes: harness or connector, short circuit between transmission range switch and TCM, or the transmission range switch. That's it. This has already had a transmission range switch put in it. As far as checking the signals, they want us to look at the switches. We had those up, and then monitor for each one. And I remember it saying 10 seconds. Where did I see that? Let's go back to the scan tool and do that. So the indicators were not important, but the drive switch, neutral switch, P switch, R switch, the L switch. So we got 1, 2, 3, 4, 5. Then we graph those, and we should have only one at a time. All right, I'm in park. You see that one says on. They said to hold it for, I read it in there somewhere, it said do it for 10 seconds, each one for 10 seconds. Simulating vibrations.
Oh.
Neutral. Drive. Yeah, this is all working like it's supposed to. So, I did that. All of it works like it should. Yes, check for intermittent incident. An intermittent incident. It's Nissan, man. Intermittent condition. It's just a flow chart to help you, guide you through.
Incident.
Look at their pictures. Look, water intrusion. How to recreate water intrusion. Like electrical, water, short.
I like the water.
Yeah, look, a heat gun on a module.
Nice.
It's just a generic intermittent condition I'd like to know if these are pull up or pull down circuits. I know they're 012 because without the consult, which is the factory scan tool, they're giving you options to check these. It should be battery voltage and 0. So it's 12 and 0. Let's grab a diagram. So this is my range switch, and this is a power wire right here. Goes to fuse 49. It's a 10 amp. This is a pull-up circuit. Pull-up switch input. So the red wire powers in, and then as the switch moves to the different positions, you're putting power to the low, drive, neutral, reverse, and park pins. So it's 12 volts in and then 12 volts out when the switch closes. So to have two different ones reading 12 volts at the same time, that's what's going on. You would have to have wires that are chafed and touching each other. That would be one. Not touching ground, but touching each other. And then the other one would be the switch itself, and the switch has been changed. There's not a lot to this. There really is not. It is switch or wiring. And I understand now why they didn't include the computer as part of it. It's the computer sensing two of these circuits 2, 4, 5, 6, and 7 on the module over here. Two of them reading 12 volts at the same time, or higher voltage at the same time. Now you could have, I suppose, corrosion in the computer connector too. That could maybe do something like that. But I think what we'll do, man, it'd be nice to have had some freeze frame data to know. We'll go under the hood and we'll look at these switches and see if we can make it do it. Right now we're in park. I just don't know what, it would have been helpful to know what gear position it was in when the fault occurred. Were they in drive? Were they in park? Did they just start it? You know, it's when simultaneously two of them are showing on at the same time. So we have to be in park for our tests. I guess we don't have to freeze out here. We can go in Danner's shop. I'm gonna open the door. Oh, we can't. There's a van in the way. Come out with me momentarily. Let's get a shot of the range switch for everyone. I mean, it's gonna be difficult for you guys to see it because the battery's kind of in the way. Pete had told me when he did the job that he had the battery out. But the transmission range switch is right here. You move that hand. It's this is your range switch right there. My middle finger's on it. And there is an adjustment on the cable, but I don't think that's the issue because, you know, they all work like they're supposed to. I didn't check for a bulletin for like wiring harness chafing. I maybe could do that. I was just coming out and I wanted to kind of put my hand on the connector and see if I get any changes in the data. Okay, back in the car. Let's see if we have any TSBs on this code. Let's see what we can come up with. We need some help. Nope. Nope. There's no bulletins related to the 705 code. Oh, there is one under the engine control. Hesitation on acceleration and or DTC P0705. That was in the engine system. I don't remember them complaining about hesitation, but inspect both rear tail lamp assemblies. What? For water intrusion? Why would that be in the tail lamp assembly? If water intrusion is detected, inspect the circuit board of the tail lamp bulb holders for corrosion. If corrosion is found, replace the incident tail lamp assemblies. Note, replace only tail lamp assembly where water intrusion has been detected. Do not replace the CVT assembly for this incident. Why would I replace the CVT? Okay, so remember brake lights are in here too. Remember in the code description it mentioned about the brake lights?
I think. Why
Why would that set a 705 code? There, look at that. This is a great bulletin. Hang on, I need to ask Pete something real quick. I found a bulletin on this that talks about water intrusion in the taillight assembly for this code.
Oh yeah?
I'm like, oh, how's water? What? I don't know. I haven't been able to connect the dots yet, but I know the brake switch is part of the code setting criteria for this fault. So maybe therein lies our issue, but It says hesitation problem and or this CVT 705 code. Did the customer complain about a hesitation too?
They said the light come on.
Okay.
Like I said, that it wasn't coming on the dash like the park reverse.
Back up just a bit more. That one looks newer. Doesn't look like it. Huh, doesn't look like it. Yeah, I'll look a little closer though. The fact that there's a bulletin talking about the brake light circuit, I don't know. So that's pretty interesting. I just want to see the connection and the tie-in on why the brake lights would be involved. Example of water leaking. They're showing like droplets in there. I didn't see that. Yeah, I didn't see the droplets. I'll look closer once we get inside. I just want to know how. Oh, that's what they have. We're going to look at this anyway. I don't care, even if I don't see water. We're going to look for that. So, is that maybe a ground circuit that's shared? They're not telling me why. Rear tail lamp assemblies for water intrusion. How is that going to set a PRNDL code? Exterior lights. Let's look at the lighting system. Stop lamp. Goes to the BCM. Goes to my combination meter, which would be the instrument cluster, I believe. You know, one thing I didn't do. Did I turn the headlights on? Let's see if we can make this do it. I don't know what the tie-in is. I don't want to just take those apart and look. I mean, I do. I'm gonna do that. But what's the tie-in? I don't understand how that's setting that. There's information that we don't have here, unless it's a ground that's shared. Backup lamp, so left C pillar, B19, right C pillar, B7, so they're not even using the same grounds for these, for the rear, right rear combo, left rear, yeah, totally separate grounds. Is it maybe the backup lamp circuit where it's back feeding the reverse light circuit and somehow, I don't know, that doesn't make sense. But I didn't turn the lights on, so let's go back to the scanner, and something I did not do is turn the lights on. Let's turn signals on too. Let's go in the shop and have a look. Even though those don't look wet to me, I mean, at least gives us something. Really see moisture. That lower bulb does look like it's got some poop on it. I found a bulletin for the rear tail light moisture intrusion that will set this code.
What?
Yeah. The problem is with the bulletin is it doesn't give us information on why. Let me show it to you. Rear tail lamp assembly. I was shocked to see it myself. Yeah, this is the 2012 to 14 Versa, 705. Hesitation during XL, has one or both. MIO on DTC 705. Mm-hmm. Inspect both rear tail lamp assemblies for water intrusion. I don't see it here. I'll show you the picture. If water intrusion is detected, inspect the circuit board on the back of the bulb for corrosion. So they're showing you that, and then they show you the picture of what we're looking for, right? So I'm gonna check for that.
What's the circuit on the bulb?
I don't
Is there
know.
Like any kind of, it doesn't have a light module or anything, does it?
No. That's what I was trying to find a tie-in. Like, what am I looking for here? You know, and they don't tell you what's happening. There's no info here. There's no info as to why that's happening, and I can't find a tie-in. When I pull up the PRNDL switch, there's nothing in there for lighting. It just goes directly to the engine. Goes directly to the TCM. And then when I pulled up the wiring diagram for the external lights, I couldn't really find a tie-in. I'm like, well, maybe they share a ground. No, the grounds are even separate, left and right side, you know, for the lighting. So I don't know, but that's why I turned the lights on.
Yeah.
And I thought, well, maybe tell me if you see anything that looks a little funny back there. That's parking lights.
Yeah, they're good.
Left turn,
Yep.
right turn,
Yep.
brake,
Yep.
third mount, high mount 2,
Yep.
reverse.
The left reverse light is super dim.
Ah. So why? And honestly,
So it might have to do with the lighting circuit. Then in reverse, pull up a reverse light diagram.
okay, yep. Without the bulletin, we'd be absolutely screwed on this car. So this would be the one we're gonna pull out. I'm gonna pull this apart. We'll actually, no, before I get ahead of myself, let me pull up a reverse, because I didn't do that. Reverse light diagram. So the backup lamp bulb grounds at the left and right C-pillars. It does show the transmission range switch. CVT. Manual trans, okay. It says AV control unit. What's the AV? Audio video? Still ain't seeing a tie-in. The transmission range switch would feed this directly. So the red wire, CVT, orange wire, closes, sends power down from the red wire down to the orange wire, which turns to light blue, then to yellow to the backup lamps. Let's pull up the transmission diagram again. Very strange that this would do that. So this doesn't show that at all. So starting system part of the transmission range switch would be up here, the top part, the brown and red wires. The orange is reverse, and red is the feed coming in. Let's see what fuse that goes to on this diagram. It would be this fuse right there. Fuse 49 is that red circuit. So pin 3 gets powered from fuse 49, and then pin 5 is the orange wire for the reverse lights. That's what it showed. Remember that, pin 5 orange, pin 3 red, fuse 49. Got it? Fuse 49, pin 3 red, pin 5 orange. Hey Danner, survey says we got some bullshit wiring diagrams. So check this out. This is the reverse light circuit, right? What you have is your transmission range switch. That circuit. So red wire for the CVT. It'd actually be this one, right? Red wire. It's fuse 49. Powers the red wire. When it goes into reverse, comes down, powers that circuit for the CVT. Orange. Then it comes down to the reverse lights. It goes orange to light blue to yellow, right? Reverse AV control unit. Maybe that's like a backup cam or something. I don't know that for sure. That's my guess. All right.
Yeah.
So it is absolutely pins on the switch 3 and 5 on the reverse switch. Pins 3.
And then as far as
5.
what the computer's seeing, it's all data line
But
shit.
no. Look at this.
Because that's what I saw when I looked it up.
Look at the TCM diagram. They're not giving us the whole thing. We are being lied to by this wiring diagram. So this is the CVT.
When they bought the information, it wasn't all transmitted.
Yeah, here's the CVT transmission diagram. This is where our range switch is. Here's your range switch. Pins, look, pin 3 is red, pin 5 is orange, park, right?
Reverse.
And reverse, all it does go straight to the transmission control module.
Oh.
They're lying to us. So if that wire's corroded, I don't know, we're getting a backfeed on the reverse. My guess is we're getting a backfeed on the reverse light circuit. Probably, maybe even when it's not in.
That's what my question was.
When it's not in reverse.
Is it going to crash because it's shorted in reverse and that whole time it's messed up?
Well, here, but
how could it backfeed
I don't
when
know.
it's not
Let's be clear about what we know for sure according to these two diagrams.
Nothing.
It is 3 and 5, same pin, same colors. It is also the same fuse. I don't know why that just got grayed up. Fuse 49. Fuse 49 is the power feed for that red circuit, and that red circuit is that guy right there that comes into the range switch on pin 3, comes out on pin 5, and nowhere in that is it showing me the reverse lights, but they are on that circuit.
I just want to know how the backfeed happens if it's not in reverse.
Well, here's the circuit design. It's externally powered and then internally switched up, so it's a pull-up design. So
is it expecting to see you hit reverse before it goes into drive?
No,
it might be a logic
the
change?
code setting says when it sees 2 so there's 5 positions: park, reverse, neutral, drive, and low. And it says, the code says it sees 2 of those showing on at the same time.
Okay.
And so the way that the circuit works, it's a pull up. So the orange wire, for example, when the switch closes to R, it's going to increase voltage on the orange circuit and sends it to the computer. So we would have to have the orange wire being sent power.
because it's spliced in here
Yes,
after that. Okay.
it's spliced in after.
Yep.
And so corrosion,
Oh, wow.
yeah. And it was this left one that was dim. So the question then would be, I don't know, it would be nice if we could prove it before I pull this apart.
Well, you could probably make it happen.
Well, that's what I'm
spraying
thinking.
it with water.
Or just wiggling it maybe. We'll watch this screen while I pull this apart. We get lucky on this one, Caleb. Without a bulletin, ain't no chance if we were gonna fix this. No chance, especially because there's no tie-in. The wiring diagram's wrong. What we need? 10 millimeter. Give me a 10 millimeter, Danner.
Good luck.
Yeah. I didn't want to unplug it electrically because I want to play around with it plugged in. See if we can make this code set. I don't see the corrosion or why that one would be dim. This was the reverse light one. Just maybe is it corroded inside? No, it is not. Let's put this back on and tell me if that still looks dim, because I might end up doing a voltage test and might do this differently. Do they? Danner, tell me if that's the same brightness now.
Yeah.
Is it?
Yeah.
So I don't have the corrosion, but all I did was pull the bulb and put it back in. So it must have had some
Like that little burn mark there in the flat spot there.
Yeah, how in the hell is that gonna mess up the park neutral switch? You know? I'm just not seeing it, man. It's just,
Yeah.
it just doesn't make sense.
So you're telling me I can't charge her $100 to put a bulb in it?
You know. I'm gonna check the other one too, even though that looks okay.
So you don't even know why it was dim, whether
No.
it was the...
I don't. But even if it was, back feeding on a ground, it's a pull-up design. It would need to have high voltage on the reverse light circuit when it's not in reverse. How's that going to do that?
Yeah, without a short in here, it can't.
Well, I mean, unless it's back feeding from the other lights.
Well, here's the power circuit right here. Comes through your plug area right here, and every joint soldered or glued, and then
Yep.
here's your positive that goes back down under.
Yep.
And then all the outer ones are your grounds.
Right.
So I could see,
If it was heavily corroded in here.
it was like arcing somehow, you know what I mean?
So then you'd have ground voltage that would be elevated that would maybe backfeed through the bulb. But then it's a stretch. Without seeing the corrosion?
Seeing that, I'm with you.
Well, we're gonna look at this side too. I ain't seeing it, man. I didn't see the moisture. I'm not seeing how this would backfeed without, I mean, that one was dim, but the diagram's wrong in what I have. And so I'm not really sure I could trust it from this point. I was excited. I still kind of am, but I can't prove it to everyone. I can't prove that dim bulb and that contact issue on the bulb itself, which is what we had there, would be enough to cause this condition. Here's the problem and where we are right now with this car. our wiring diagrams are wrong. The wiring diagrams I have for this car are wrong.
Yeah.
So I can't trust it. I'm not going to be able to put 2 and 2 together. I'm not going to be able to explain to everyone.
What he's saying is he can't fix this.
That's what I'm saying. Without proper service info, we give this back to the customer and see what happens. See if that, what we just touched.
You want to put a bulb in that one just in case the bulb's shortened somehow? I don't know.
It's a single filament bulb. You know, it sends power to it. It wouldn't be the bulb. It would have to be something in the housing.
Unless the bulb somehow shorted inside. I don't know if that's possible.
Well, change the bulb.
You know, and then you get a voltage spike going.
Do you want to
pop the fuse or something?
Do you want to change this one too?
Yeah, we'll just throw 2 in it.
All right, we'll change this bulb too then. In my opinion though, it's got to be like the circuit ground that would backfeed, you know? That's the only way you're going to get high voltage on the reverse light circuit.
So the other thing, does that go into the body and run through the body, or you know what I mean?
Well, it says for the grounds, it's on the pillar, the C pillar on both sides. Here, plug this bulb in, and then I'll put it in reverse. Yeah, I mean, we could have a problem further upstream, but without a good wiring diagram that's going to show me.
This harness looks like it runs behind that seat and probably goes down below the door trims crap.
Well, just tell me that these are lit up normally in reverse. What I was looking for when I'm taking these bulbs out is like a mushroomed end where it's short circuiting into another circuit. We don't have that. Well, did we fix it? Do we have, it's gotta, in my opinion, the only way that that's gonna happen is if that reverse light circuit is getting backfed. It is on the same circuit according to the 2 different diagrams. And that reverse light circuit's getting backfed voltage when it shouldn't be, which corrosion could do that. But I just don't see that that was the case in what we were looking at. I don't see it. I don't think that that bulb being dim was it. I think the backfeed would be coming not from the reverse light circuit itself, but from either the parking light or turn signal circuit, given that this circuit board, if you want to call it that, is all sharing grounds. And with corrosion, you can get a backfeed from the reverse light power feed circuit. Here, wait, let me look at this again. So this is the reverse, yeah. So if you had corrosion, say between the turn signal circuit here and this one, so this is the reverse light power that comes in, this leg, you could have corrosion between here and corrosion between here and here that would do it. Could do it. And I don't see it. I don't see it. Unless, is that close to touching? Ooh, that's real close to touching. But that's the wrong bulb. But I was just looking at the track. But right here is what I'm looking at, is how close those are to touching each other. This is the reverse light pin. Ouch! Hot, I burnt myself. Bulb's hot. That, in my opinion, that's the only way that this would do that, is getting a cross feed. It can't be from the bulb itself. Where's your alignment brake tool? The brake pedal depressor? I'll just use a pry bar. Brake pedal depressor.
Nice.
Nope. I don't think so, Caleb. I don't think so. Only way this happens, Dan, is if you get back feeds from the parking light, turn signal, or brake light circuit. Because it's a pull-up design.
So is there like a body ground that jumps to the engine up front that
No.
cause like any kind of backfeed or?
It would have to be the grounds back here, and they're 2 separate grounds, and they're on the C pillar.
No, but I mean like from there, it's gonna go, it's gotta get back to the battery somehow. So is there like a frame the battery jumper or, you know what I mean? That's all, I mean that would be the only other oddball you could think of, but you wouldn't think a high resistance ground would do that.
A high resistance ground would would, but it would have to be, like I said, they're individual. And for, you know, a body ground like you're talking about, like getting back to the battery, that's not what I'm referring to. I'm talking about the ground for this housing. And there's separate grounds on the C-pillars, but the only way that we're gonna read reverse when we shouldn't be is getting backfeed from these other lights. The only way we're gonna get a backfeed with these other lighting circuits is a bad ground or a backfeed from corrosion or like a bulb that's like messed up. Not the dim bulb that we have, but like a bulb like the parking light and stoplight circuit where like if the two of those were like touching each other, that's a stretch too. That doesn't make sense. But I'm excited about the bulletin. It's still, I suppose, possible. I just can't prove it. The bulb was dim, but dim bulb's not the issue. That's just the single circuit itself. That circuit gets powered up. That bulb was dim for just contact on the positive terminal of that single filament bulb. I don't think the dim bulb was our issue. But I'm not confident in our wiring diagram anymore. After I'm seeing the reverse light circuit and how it's operating, the reverse light circuit is absolutely operating off of that range switch. And my diagram's wrong. So we could have like some other voltage crossing into this reverse light circuit because there's another connector and like we're in the right area potentially, but not the exact pinpoint location. In other words, it might be further up. Our problem could be further up in this, but I'm pretty confident that it's going to be revolving around the reverse light circuit. There just isn't a lot to this. There really isn't. It's a very simple circuit. I wish I had a better diagram. When I saw that dim bulb, I was like, bingo.
I know.
Bingo, that's it. I wanted to see corrosion, but we did not. But the dim bulb does suggest a corrosion issue. Here, look, this connector, in my opinion, would be suspect, this area. What else goes through this connector? This E55,
55 and E21.
F55.
I don't know if you're gonna find that on.
I know.
It's probably right under the dash somewhere by the left kick panel.
All right, well, I'm wrapping it up here. I think from this point, we give this car back to the customer, have them bring it back if it does it again. If it doesn't, I don't have a good explanation for you guys on that dim bulb, on the reverse light circuit on this. I don't think that was our issue. I think when Pete did the job, changed the front switch, it came back on immediately. So I'll have Danner mention to the customer to pay attention to when it happens, to when that light comes on, and if it's raining out or not. Maybe that's a factor, I don't know. The bulletin was cool, excited to see that. Can't connect the dots there. This is another one that hopefully we'll have some kind of follow-up for you guys. And hopefully I can research this a little bit more and get some better service info because we clearly have some incorrect diagrams. And I'll have to let my Snap-on friends know about that and let them correct that diagram on the transmission. But the brake lights or reverse lights are definitely controlled by that same switch. And the diagram does not show that on the TCM side. So that's a problem. And when you're fighting service information and intermittence at the same time, that's a recipe for just losing from the get-go. Recipe for disaster. All right, I'm stopping here. Hopefully we'll have a follow-up for you guys. If not, don't forget about that bulletin on these. Absolutely a key piece of information. Service info is key, guys. Hopefully, again, we'll have an update. If not, we'll see you next time.